Okay, today I'm going to talk about histograms. This is section 2.2, and in another video I'll talk about 2.3. Okay, so a histogram is a way of graphically seeing a frequency table so we can look at the shape and so forth. A histogram, there's two different parts. I'm going to just go here so I can explain. The x-axis, it has to do with the class. We usually use class boundaries. And the y-axis has to do with the frequency. So this one has to do with the IQ scores we looked at before. This is the first class. If you look at the first class, it goes from 50 to 69. So these are boundaries, our class boundaries. So go back and remember what the boundaries are. And then the height represents the frequency. Let me pick another class. So let's say we pick this class right here, 110 to 129. That'd be this bar right here. Again, we use the class boundaries, and the frequency, the height of the bar is 7. So a couple of things I want to just kind of mention here is for histograms, you do want the bars touching. So you want them touching. You don't want them having gaps in there. And that helps us tell us the distribution. Okay, so why do we want to know about histograms? They tell us the shape of the data, the distribution. Sometimes it helps us locate the center. It shows us the spread of the data, like how much it's spread out, the data, if it's all close together or all spread out. And sometimes it helps us identify outliers. Outliers are data that really doesn't go with the rest of the data. I'm just going to give an example. One semester I was teaching Math 110, and I had a student who was 70 years old. So if you're thinking of just the ages of the students, her age would be an outlier because it's not with the rest of the data. Here's another example of a histogram, but now it's a relative frequency. So if you look here, they use the percentages instead. They still use the class boundaries, but this time the height of the bar represents the percentage. Okay, here's another example. Oh, I forgot to say one thing here. Whether we look at the histogram or the relative frequency histogram, it should have pretty much the same shape, either one that you look at. Okay, here's another example. This is talking about times going through a McDonald's drive-through. Again, just kind of a couple things here. We use the class boundaries for the x-axis, and the frequency represents the actual, the height represents the actual frequency of the histogram. Okay, a couple things we look at when we interpret histograms is we look at the center of the data, the variation, which basically means is the data spread out or is it all close together. What I mean by that is, like, let's say you guys took your first test and your scores range from 80 to 95. That means your scores are pretty close together. There's not a lot of variation. But let's say that the other class took the test and their scores range from 30 to 100. So that's what we mean by variation, is the data spread out. We'll talk more about that when we talk about the standard deviation in chapter 3. Okay, we'll look at the shape of the distribution. We'll talk about the shapes in just a minute. Look at outliers. And then we don't talk about time, so you can skip over that one. You just mark that through. Here's some common shapes that we'll talk about. The one on the top right, the green one, is called a normal distribution. A lot of things in the real world are normally distributed. We'll talk about this more in chapter 6. The one on the right, the red one, is called uniform distribution, which means if you look at all the heights, they're all about the same throughout. And then these two on the bottom, we have skew to the right and skew to the left. Okay, if we take a look at this one, it looks pretty close to a normal distribution. Let's talk about arm circumference of, I think, men or women. It doesn't say. And we expect that to be bell-shaped or a normal distribution. Skewed means it's not symmetric. It extends more to one side than the other. So here's an example. It doesn't say what this data is again, but there's more on the left side. So they call that skew to the right. So it kind of skews to the right here. And then here's another example, skew to the left. Okay, so that's it for section 2.2. I'm going to stop here and make another video for 2.3.